Notice in here that this has x going to negative infinity. So this is going to be a negative infinity. This is going to be a negative number squared, so that's positive. Add 1, it's still positive. Take the square root, it's still positive. So if you just get an estimate and ignore the 1, then that right there is the way to get absolute value. So you square it, it's positive, square root, it's positive, and you get the number back again. So that means just that part is a positive infinity. According to the directions, x is a negative infinity, so the 2 should cancel out and we get the answer 0. So we could say that's approximately, so if we're talking about infinities and infinity squared, adding a 1 is not going to change the answer. So we can approximate this by dropping out the 1. We've got the limit as x approaches negative infinity, and then it's going to be x plus the square root of x squared, which is equal to the limit as x approaches negative infinity of x plus the absolute value of x. And so that's going to be negative infinity plus infinity, which equals 0 in this case. You've got to be careful with infinity arithmetic. With regular arithmetic, negative infinity, or excuse me, a negative 7 and a positive 7, they're always going to cancel out and give you 0. In here, with infinities, it happens in this case, but not always. With an x and the absolute value of x, they're equally powerful. So when one goes to positive infinity, the other one goes to negative infinity, they cancel each other out, only because they're equally powerful. If this had been an x squared, or this had been an x squared, so one of them was more powerful than the other, then wherever that one's going, it's going to win. Okay, so we get the answer 0 and take a look at the graph. Alright, zoom standard to begin with, and you'll see the left hand side is very close to 0, where the right hand side takes off, but this said when x goes to negative infinity, so that's asking about the left side of the graph. And if we trace it for some numerical evidence, you'll see that the y value very rapidly is becoming close to 0. So I'm pretty satisfied with the 0. Here's another interesting one now that I saw this right side of it. What if it was take the limit as x approaches positive infinity of the same function, well then this would be a positive infinity, just like we got before, and this would be a positive infinity, so that would go up to positive infinity. But notice that if we use the approximation idea and say, well, since it's going to infinity, adding 1 isn't really going to change the answer, then we would have x plus, and since this is positive, I don't really need to put the absolute value. When it was negative, I needed to put that, showing that squaring is going to get rid of the negative. But anyway, this one is already positive infinity, so I don't really need to put that absolute value. It's x plus x. So in other words, it's the limit as x approaches infinity of 2x. So the answer here would be 2 times infinity, which is infinity. But more interesting than that is it's basically following the line y equals 2x. So yes, that side is shooting up to infinity, but if I also graph y equals 2x, and I'll make this one a thicker line, you should see that this thing right in here, as it went up, it's pretty much the line y equals 2x. Wow, added fun for no extra cost.